Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. And take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called Knotted Regional Constraints by Bellamy. And here are the rules. We have normal Sudoku rules apply, which means place a digit in every single box with that. No, I was trying to think of a different way of saying this, but place one digit in every single cell from the digits 1 through 9 such that there are no repeats in any row, column, or designated 9-cell region. Yeah, I like that. That's not too bad. We also have killer, where digits do not repeat in cages and sum to the small clue in the top left corner if given. So, for example, these 3 digits must add up to 9. You could have something like 1, 6, and 2 there. That would satisfy that cage. We also have Renban, where purple lines contain a non-repeating set of consecutive digits in any order. So you could have something like 3, 5, and 4 here, and that would work for this Renban. Or 3, 5, and 4. I don't know why I put 3, 4, and 5 in that order. Anyways, that's how Renbans work. And then you have German whisper lines, where adjacent digits along a green line have a difference of at least 5. So, for example, if this were a 3, this would have to be an 8 or a 9, because those are the only digits that are 5 or more away from 3. For Dutch whisper lines, we have adjacent digits along an orange line must have a difference of at least 4. So if, for example, this were a 3, this would be 7, 8, or 9, because those are the possibilities between those are the digits that can be 4 or more away from 3. Along digits, thermometers, for a thermometer, digits along a thermometer increase from the bulb to the tip. So as an example, we could have something like 2, 3, 4, 8, or something along those lines. What we could not have is something like 2, 5, 4, 8, because it's decreasing from the 5 to the 4, and we must be continuously increasing from the bulb to the tip. And then finally, and this is probably the most important rule, we have constraint regions, where each constraint type may contain no repeated digits anywhere in the puzzle. And these constraint types are basically the rules that you have, right? So for each rule type, for example, for all the killers, you cannot have repeated digits in those constraint types. So in all the cages, we cannot have repeats. Along all the Dutch whisper lines, we cannot have repeats. Along all the Renban lines, we cannot have repeats. So as an example, Bellamy gives, for example, if one thermo contains a 5, then no other thermo may contain a 5. Right, so you can't have repeats anywhere along all the thermos either. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now I'm going to get started. Let's go. Okay. So, what do we want to tackle? These digits are from 1 through 6. That doesn't tell us very much, though. This digit must be at least 1. So I like going along thermometers and seeing what the minimum could be for the thermometer. And then going back from the tip to the bulb, looking at what the maximum can be. So then that way you can figure out, you can restrain the digits within those cages a decent amount. It's not always going to be that great. 2, 3, 4, 9, 8, 7, 6. This is 1 through 6, 2 through 7. 3 through 8, 4 through 9. That's not going to be that restrained. This is 9, 8. You can also do it reverse, 9, 8, 7, and this is 1. So 1 through 7, 2 through 8, and 3 through 9 here. Okay. Oh, interesting. Where are these three digits in box 4? They can't be here because of the regional constraints or constraint regions. They cannot be here. So these three digits must be the same as these three digits, which means they are the same as those three digits in column 2. Same with these. These three digits must not be here and cannot be here. So they must be the same as these three digits, which means they're the same as these three digits. And we are left with these three digits then. And these three digits have to be the same as these three digits, right? Because the light gray and the green are already different digits than the red. And the red have to be these three. Okay, that's interesting. Does that help with anything else? Not particularly. Oh, interesting. These three digits, similarly, okay, so these three digits have to be this different than these three digits, so they must be those three digits here. Oh, that's really interesting. So therefore, they must be the same as those three digits. These three digits cannot be these three digits, cannot be these three digits, so they must be the same as those three digits, which means they're the same as those three digits. Which leaves us one remaining set. Here, here, and here. That's interesting. We have the same with these orange ones, right? Right. Um, hmm. And we have the same with these Ren bands. Oh, that's interesting. Okay, so the Ren band, this one cannot be the same as this one. And it cannot be the same as that one. So this one has to be the same as that one. This one obviously cannot be here, so must be here. So this is E, well, it doesn't have to be light or green. Okay, so so this is red. In this constraint, red cannot be here or here. This red band cannot be the same as this. The red has to be the same as this. So this red band cannot be the same as here. So we're going to have to mark a different color. So this one is a different color. It cannot be the same as this ren band. This ren band can't be here and can't be here. So it has to be here. And this dark cannot be the blue. And it can't be this, so it has to be here. So this is dark. This then has to be red. And this is red. And this is blue. Okay, that's very interesting. We don't know if blue and dark are the same as the light and green. We do know red is the same. So they must add up to... The reds all have to be the same. So if it's 1, 2, 6, it has to be 1, 2. Oh, it cannot be 1, it cannot be 1, 3, 5, because we know there's a ren band here full of the reds, and it has to be the same. And 1, 3, and 5 are not consecutive. So this cannot be 1, 3, 5. It has to have a 2. So this has to have a 2 in it. And it's either 1, 2, 6. So this is either 1, 2, or it's 3, 4. Since this is 1, 2, 3, 4, that means this is low. And on a German whisper line, you alternate between low digits and high digits, right? Because 1 can be next to 6, 7, 8, 9, 2 can be next to 7, 8, 9, 3 can be next to 8, 9, and 4 can be next to 9. So next, a low digit, 1 through 4, always has to be next to a high digit, which is 6 through 9. And then you have vice versa. So this has to be 6 through 9, but it's next to two unique digits on a German whisper line, so it's actually 7 through 9. And then this has to be 1 through 4, but it cannot be 2 because we know 2 is in the red digits because it's either 1, 2, 6 or 2, 3, 4. So this can never be 2. Since this can't be 2, this can't be 3, this can't be 4. All the dark digits and the blue digits are consecutive, but that doesn't translate to green and light, though. Okay. These three digits are the same as these three digits. So these three digits... So where's the 5 in box 8? These three digits are not the same as these, and cannot be the same as these, so they are the same as these. One of these digits has to be a 5, because the rest of the digits, quote-unquote, are on a red band line. Sorry, not red band line, a German whisper line. So this has to be a 5 here. What does that tell us? I'm not really sure. Let's see. So the 2 can be either here, here, or here. But that doesn't really tell us much. So this is either 1, 2, and this is 6. Or this could be 2, 3, or... Cannot be 3. It's 2 or 4 here. That's interesting. So the only way this is 7 is if this is 1, this is 2, and this would be 3. So that would be 4. That seems possible. Since this is 4, 4 cannot be in the rest of the German whisper line. So that would have to be... I'm not sure what that would have to be. It would have to be not 4. So you would have, and you would have 1, 2, 7 already taken up. So 3 would have to be between 8 and 9 if that were the case. Okay, so let's go through the possibilities here, I guess. If we have 7 here, and this is 1 and 2, this would have to be 4. Sorry, this would have to be 3 to be red band. This would have to be 4. This would then be 3 in between 8 and 9. That's possible. Okay, so that's a possibility. If this is 1, 2, and 6, this is a 1, 2 pair. This has to be 3 or 4. I guess part of the question is, can this ever be 6? Maybe? It would be 6, 1, and something else. Oh, that's interesting. I don't think this can ever be 6. So, again, if we try to have a 6 here, it would be 6 and 1 here, right? So you would have a 6 and 1. So 1 could not be here. But 6 cannot be here, therefore this would be 2, 3, and 4. And we have, yeah, and this would be a 2, 3, 4 triplet, and this would be a 3, 4. Which would mean that 4 digits in box 7 will require the digits 2, 3, and 4, which is not possible. So this can never have a 6 here. Which means this can't be 6, this can't be 6, so this has to be 5 and 6 here. That's interesting. Does it tell us anything? Not particularly. Can you have low, low, and high here? That would mean there are 4 lows, so one of them would have to be 4, the other one have to be 9 in between. These would both be low. Possibly. I'm not sure. Oh, wait. If this is 2, 3, 4, can you ever have 2 consecutive digits being renbands, which are not including the 2, 3, 4? No. So this must then be 1, 2, and 6. So this has to be 1, 2, and 6 here, which means this has to be 1, 2 to be consecutive, and this is 6. So since this is 1, 2, this cannot be 1. Therefore, this digit is in between a 1, 2 and a 3, 4, so it cannot be 7. It's 8 or 9 here. This is a 1, 2, 6 triplet. That means this has to, one of these is 3, 4, 5. The other one is 7, 8, 9. So this is 1, 2, or 6. 1, 2, 6, 1, 2, 6. These are 1, 2, 6, and 6 cannot be here and cannot be here. So this must be a 6 here. Hmm. So this is not 3, 4, not 3, 4, 5. So this is 1, 2, 6, 1, 2, 6, 1, 2, 6 here, which eliminates 6 here. That doesn't tell us much. 3, 4, 8, 9. 1, 2, and 6. So 1 and 2. So 6 can never, well, 6 can never be here. If this is 6, the problem is it has to be next to 1 or 2 on the Dutch Whisper line. And 1 or 2 is part of the orange of the red set, so this can't be 6. This is 1 or 2. 1 or 2 can be next to 5, 7, 8, or 9. That's possibilities here. If this were 6, this would be 7, 8, 9. It's still possible. This is a 3, 4, 5, 7, 8, 9 set, but that doesn't really help us very much there. We have 1 red here, 1 red here. The rest of these, one of these has to be red. So this cannot be 2, because if this were 2, the problem is this would be 1, and we already have 2 digits on thermometers that are from 1, 2, and 6. So this can't be 2. Since that can't be 2, this can't be 3. In row 7, we cannot have a 1 or 2 because of the 1, 2 pair there. So this has to be 3, 4, 5, 6, 7, 8, 9. These cannot be 5 or 6 or 1, 2. So it's 3, 4, 7, 8, 9 as possibilities there. So one of the 1 or 2s is here. So whichever one we have here, I guess we'll make this orange and this yellow. This has to be orange, which means the yellow has to be somewhere here. This must be the yellow one. What else do we have? 3, 4, 5, 7, 8, 9 on the red bands. Thermos, cages. Hmm. We have 8 digits on Dutch whisper lines, so that's not too helpful there. Hmm. Do we have anything else? No. If this is 6, this would have to be guaranteed 7, 8, and 9. So this would be 1 or 2. This would be 1 or 2. This would have to be a 3, 4, 5. So this would be a 3, 4, 5 triplet. This would be 7, 8, and 9 then. Yeah, seems feasible. What else do we have? These 3 digits are the same as these 3 digits, and these 3 digits cannot contain a 4. So this does not have a 4. We know one of the 1 or 2s is here. We're not sure which one. It can't have a 6 because it doesn't have a 6 here. So this is only 1, 2, 5, 7, 8, 9. So this is 5, 7, 8, which means this can't be 5, 7, or 8. This has to be 6 through 9. So one of the 1, 2, or 6 has to be on this Dutch whisper line. But it cannot be 6 here again, right? Because if it is 6, the problem is it would be next to 1 or 2 on this Dutch whisper line. And it can't be. So 1 or 2 is here. 1 or 2 is here. That means 6 has to be here on this Dutch whisper, not on this Dutch whisper line, and not here. So again, these 3 digits must match these 3 digits because you can't have duplicates along the constraints. So this is, and it cannot be 6 because 6 has to be next to 1 or 2, but that would eliminate 1 and 2 here. And that would be an impossibility. So 6 has to be here, which means this cannot be 6. So one of these 2 is 6 and one of these 2 is a 6. We're not sure which. Therefore, this can never be 1 and 2 here. So this is always 3, 4, 5, 7, 8, 9. This is 3, 4, 5, 7, 8, 9. And it could be a 6 here. We don't know. So we know 6 is one of these 3. 6 has to be one of those 3. 1 or 2 is one of here. What other constraints do we have? I'm not sure. We don't know where the 1 or the 2 is here. So 5 has to be here. These 3 digits, so these 3 digits are the same as these 3 as the same as these 3 digits. These 3 digits cannot be here. These 3 digits cannot be here. It can't be here, so it has to be the same as those 3 digits. Therefore, these 3 digits are the same as these. So 5 has to be one of these 2. We're not sure which. 5 also has to be one of those two. So this is specifically 5, 7, 8, or 9. This is, again, these are 3, 4, 7, 8, 9, and this is 5, 7, 8, 9, right? Because 5 has to be one of these two. Hmm. If this is 5 here, that has to be with 9 because it can't be with 1 or 2. And then, interestingly enough, this would eliminate 5 and 9 as possibilities here. So that would force this to be 7 and 8 here to be with 1 or 2. And then that would require 3 and 4 here to be next to 1 or 2. And that's not going to work, right? You can't have a 6 here. So again, this cannot be 5 here. If this is 5 here, it requires a 9 to be with it, because the 5 can only be next to 1 and 9 on the Dutch Whisper line, and 1 is already taken by these sets. Therefore, this would be 7, 8 here. So we would not have 5, 7, 8 here, or 9, and it would cannot have a 6, because only one of the reds can be on this, and 6 would have to be next to 1 and 2. You'd have 1 and 2 next to 3 and 4. So 5 cannot be here. Okay. I think that's a similar point, though, for 9, too, right? No, not necessarily. So one of these is 3 or 4. And the other one is... Okay, so 6 can never be here. 6 can only be next to 3, 4, or 9. Sorry, 6 can only be next to 1 or 2 on a Dutch Whisper line. So this has to be 3, 4, 7, 8, 9. 6 is the missing digit then on the Dutch Whisper line. So this has to be 5, 7, 8, 9 with 3 or 4. One of these is 3 or 4. 3 or 4, 1 and 2 cannot be next to 3 or 4, so it has to be 1, 2, 3, 4 on the outside, and you have to have, can't have 5 here, it has to be 7, 8, and 9 on the inside. Because 5 can only be next to 1 and 9. One of these is 3 or 4, the other 3 or 4 has to be here. So this is 3 or 4. One of these is 3 or 4, and the other one's 1 or 2, which means this has to be at least 7, 8, or 9 here. Therefore, one of these is a 5 here, which means 5 cannot be here. 5 has to be one of these 3, and 5 then has to be one of these 2. Interesting. It's pretty cool, actually, how the constraint regions are being used here to restrict things. So we're missing only a 6 from the Dutch Whisper lines. So we have everything else. Does that tell us anything? Not particularly right now. Uh... Huh. The green has to have a 3 or 4. Oh, this cannot be 5 here. Because 5 has to be one of these two, which means it can't be here. It has to be one of those three, which means it can't be here. So again, this becomes 5, 7, 8, or 9 as possibilities. Interesting. What does that mean? I'm not really sure. This is 3, 4, 7, 8, 9, 3, 4, 7, 8, 9, 3, 4, 7, 8, 9. This cannot contain a 1 or 2, so this is 3, 4, 6, 7, 8, 9. Yeah, I'm not sure what this tells. Oh, 5 has to be one of these two. So since 5 is one of these two, 2 can never be next to it on a Dutch whisper line. So this is 1, which makes this 2. This can't be 2 here. These can't be 1. Therefore, 2 has to be on one of these sides. Since 2 is one of these here, okay, this is not 2. This one of these is 1 here, which means this can't be 1. This is 6, which makes that a 2. This 6 eliminates 6 here, so that's 1, which this 2 makes this a 6, which makes this 7, 8, and 9 to be on this. So this cannot be 7, and this 8 has to be somewhere in box 1. Well, this 8 must be part of this set, right? Because these 3 digits cannot be here. It cannot be the same as these. So it has to be the same as these. And therefore, this must be a 5, 8 pair. Which eliminates 5 and 8 in the rest of the row. So this can't be 5 or 8. This can't be 8. And it can't be 7. So this has to be 9. So this is 9 with 2 or... this can't be 8 or 9 here. So this has to be 7 here, which means this can't be 7 for that 7. So this has, sorry, this can't be 7 here, so this has to be 7 here. The 7 can only be next to 3 out of 3 or 4, so this is 3, which means this can't be 3 here. This is a 2, 4 pair. This can't be 7 or 9. This becomes a 1, 5, 8 triplet, which eliminates 1, 5, and 8 from the rest of, well, okay. This cannot be, so these 3 digits are the same as these 3 digits here, so this has to be 1 and 5. Therefore, we cannot have 4 here, 8, or 9. This has to be a 3, 6, 7 triplet. That eliminates 3, 6, and 7, and 5 and 8 in the rest of row 1. So no 3, 7, or 8. No 3, 7, or 8 here. No 3, 7, or 8 here. This cannot be 4, 9, or 5, 8. This becomes a 3, 7 pair. That leaves this digit as a 3. This 3 eliminates 3 here, so that must be 4. 4 can only be next to 9 on a German whisper line, so this is 9. 9 has to be in the light gray, so this is a 9, because that's the only digit left. We need a 3. We don't know where that is. This is 3, this has to be 4 then. So this is 4. And we need a 9 in column 3. It cannot be here. It has to be here. So this is 9, which means, and there's no more 6 through 9s on the thermometers. So this can't be 7. This is 3. This can't be 6. This is 1 or 2. This must be 1 or 2 because it's the smallest digit left. This can't be 6, 7, or 8. This can't be 6, 7, 8, or 9. This digit must be less than that, so it has to be less than 5. This 3 eliminates 3 here, so this is 4, which makes this a 5. And we have a 1, 2, 1, 2 pair. This is 3, this is 7. This must be 3, 4, and 5 to be consecutive. This can't be 3, 4, or 5. It's a 7, 8, and 9 triplet, which eliminates 3, 4, 7, 8, and 9 in the rest of the column. This can't be 8. This is 5. This is 4. This is 9. This is 8. 1 or 2 is here. 1, 2, 6 is here. We have 3, 9, and this is 5 or 8. This is 4 and 9, so 4 and 9 cannot be here. 4 and 9 cannot be here. This can't be 9. This can't be 7 or 8. This has to be 3 then, which makes this 5, which makes that a 4. This can't be 3 or 4 because of 3 or 4 in the row, so this is 5, which means this can't be 5, this can't be 5. This is 7, 8, 9, but 9 cannot be here or here, so this is 9 here. This is a 7, 8 pair. This is 4. 4 and 9 both have to be here, so this can't be 9. Therefore, 9 has to be here. This cannot be 4 or 9. So 3 cannot be them. Actually, this 5 and 7 and 8 are eliminated here. And 3 eliminates 3 here, so this has to be 6. This can't be 6 or 7, so this is 3, which means 3 cannot be here. This cannot be 6 then. This can't be 3 also, so we have 5 with 7 or 8 here. The rest of column 4 is what? 1, 2, and 4. But 4 cannot be on the German whisper line, or cannot be on, yes, on the German whisper line because of the constraint regions. And this 1 or 2 must be the yellow one. This 1 or 2 cannot be next to 9. It can be next to an 8. It has to be next to an 8 because it can't be next to a 7. If it's a 7 here, 7 can only be next to 1 and 2, but we're missing one of the 1 or 2s here. Therefore, this must be 8. This must be 3. 8 cannot be here then. This is a 5, 7 pair, which eliminates 5 and 7 from the rest of the row. So this is 8, which makes that 7. This cannot be 4 or 9, so this has to be the 1 or 2. And it must be the orange 1 or 2. This is then a yellow 1 or 2. This can't be 1 or 2 because of the 1, 2 pair in the box. So this is a 4, which makes this 2, which makes that 4. This 2 means all the yellows are 1, and all the oranges are 2. This has to be a 9 because of what's left over in that row. This has to be 5, and we have a 7 with it. So it's a 5, 7 pair. Remaining digits in row 8 are 3 and 8, but 3 has to be a light. So this cannot be 3. This is 8. This is 3. This 8 eliminates 8 here, so it's 5 and 8. This 5 eliminates 5 here, so it's 7 and 5. 1 eliminates 1 here and here. The green digits are 4, 7, and 8. This can't be 4 or 7 because of the 4, 7 in the row, so this is 8. This can't be 1 here. It has to be 2 or 6. This 1 eliminates 1 here, so this is 5, which makes that 1. 5 eliminates 5 here, so it's 7, which makes that 5. 7 eliminates 7 here, so it's 6, which makes that 7. This is 8, which means this can't be 8. This is 5. These can't be 8. This, what else do we have? We have a 2, 6 pair. The remaining digit, this remaining digit in column 5 is 3. That eliminates 3 here, so that's 4 and 3. This 4 eliminates 4 here, so it's 7 and 4. This 1 eliminates a 1 there, so this is 2, which makes this 6, which makes that 1. This 6 eliminates 6 here, so this is 2. This can't be 2 or 1, so this is 6, which makes this a 1. This 6 eliminates 6 here, so that's a 2. This 7 eliminates 7 here, so it's 8 and 7. That leaves us as an 8, and this as a 6. And that's how you solve it. Yeah, I'm not sure I would consider this easy. I think for me it's in between easy and challenging. The individual constraints are very interesting, right? The constraints with the rule sets are very interesting, particularly the way that they are created here. So that was actually very cool. But it still took actually some thought to get through here and here and then here, right? Then once we got this, we could understand that this had to be 6 because this had to be 1, this had to be 2. There could not be So this had to be 6, 7, 8, and 9, which basically freed everything else up. Yeah. Pretty cool rule set and pretty cool use of those um, restrictions. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.